we're going to go ahead and take a look at normal distribution. Now, it's really a density curve, and we've been looking at, for the most part, some density curves if you look at the general shape of what we've been doing with StatKey. Now, we've done some Bootstrap distributions. We've done some randomized distributions. You notice they all ended up being very similarly shaped. They're all kind of bell-shaped. This bell shape leads us to the idea of a density curve. A density curve is an ideal histogram that's all smoothed out, where the total area underneath your curve is 1, and the proportion of any population in any interval is the area under or over that interval. So if we go back to our Atlanta commuters, you kind of draw in a smooth curve going through kind of the tops of your little dot graphs, and then you end up getting this bell-shaped curve, which for the most part is a normal distribution. Now, if you're looking for the area between 30 and 31, as in what portion of the Atlanta commuters have a travel time of 30 to 31 minutes, well, that proportion of commuters that have a travel time between 30 and 31 minutes would be the area of this red, from 30 all the way over to 31. And in this case, it's about 0.15, or if you change that into a percent, or 15%. A normal distribution is a symmetrical, bell-shaped density curve. A couple key features about our normal distribution. The mean is always at the center. The standard deviation controls how spread out it is. So whenever you see this symbol with a capital N and then parentheses, mu and sigma, or a number comma another number, where the first number represents your mean and the second number represents your standard deviation, that lets us know that we're dealing with a normal curve with the first number being your mean, the second number being your standard deviation. So your mean is always in the exact center of your normal distribution curve. Sigma is the standard deviation. That's how spread out your data is. In this case, how spread out the curve is. And it goes one standard deviation to the right, and it would go down here. You could also go one standard deviation the other way. Or if you want another standard deviation, that would be 2 standard deviations above the mean. So you're at your mean plus 1 standard deviation plus the second one puts you here. Or to get to here, you'd be at your mean, go backwards 1, 2 standard deviations, and then we get this. So because we have this n with the parentheses afterwards, this is our mean, this is our standard deviation of the verbal SAT scores. So our mean would be directly here in the center. 70 is how spread out the data is. So if I go over 70 units, 70 under this would be 650. This would be 1 standard deviation to the right. This would be 1 standard deviation to the left. If we look at our Atlanta commuters, we have this n being normal. This is the mean from our sample right here. And this is our standard deviation of our distribution, the standard error. So our mean, if we do a normal, is 29.1. With our standard error, the standard deviation of the Bootstrap distribution is 0.93. This one here, if we're looking for the proportion that like dogs and are dog owners, with the n, the first number is your proportion, which is zero point 0.5, and that's going to show up in the middle. The second number is your standard deviation. So this bell-shaped curve right here is your normal curve, very similar to what we had over here for the general shape. We have 0.5 being in the middle, we have 0.5 being in the middle. Standard deviation being 0.1, which you can see going over here, one standard deviation puts us here. Over here, our standard deviation, which is our standard error, is also 0.1. So if I would take this and put it over the top, you'd be able to see that they pretty much match. So how do we go about finding the areas under a normal curve? Well, what do we do to figure out the area between A and B to figure out that proportion? Well, we could use calculus. But I think I don't want to do that. Even though I teach calc at another school, this would still not be my fun way to do it. So we want to use a different technique. We'll use some technology to do that for us. We can use StatKey. If you go to StatKey, go down towards the bottom of StatKey, you'll see these theoretical distributions. You can click on normal. Then it'll bring this up. You could put in your mean, you could put in your standard deviation. To put those in, you hit edit parameters. And then it will give this to you. You can either go left tail for less than, right tail for not upper than, sorry about that, greater than, or you could go two tail for a not equal to situation. Here's our endpoint, and up here is our probability, or the proportion that's shaded here. So if we look back at our verbal SAT, it's a normal distribution with our mean being this, standard deviation being this. What proportion of applicants have an ACT score of 650 or above? So we hit normal on StatKey. We come over here, we put edit parameters. We type in 580 for our mean. We type in 70 for our standard deviation. We want to be above, so we want to hit the right tail because that's greater than. And on the last slide it said 650, but I see this image here has 700. So we'll just go with 700 for right now. More likely when you hit right key or right tail, it did not say 700 here. You'd want to click on that box, type in 700, and then it would give you the p-value up here of 0.043. If you move your decimal point 2 spots, you get 4.3%. Would have an SAT score above 700. So if you wanted to do it for the initial question, which was 650, you would go down here, you type or click on the box, you type in 650, it would move this over here, and then it would give you a new number here, and that would be your proportion that would be above 650. So suppose you had a bootstrap distribution of the means of our sample of our 500 Atlanta commuters. The mean was 29.11, and for our distribution it was 0.93, which remember is your standard error. And we want to find the endpoint, a percentile, so that just 5% are smaller. Well, what would you do? You go to StatKey, down towards the bottom, you'd hit normal. We want to be smaller than 5%. So you'd want to go, well, I was going to say hit left tail, but no, you want to go ahead and edit your parameters first. So hit edit parameters, type in your mean, type in your standard deviation, then go ahead and hit left tail because you want less than 5. So we want to be so that it's just 5% or smaller. 5% are smaller, so you hit left tail. It would bring this up. You want to hit this because that's your area. You want to go and put in 5%, and 5% as a decimal is 0.05, and then it tells you the score, or not the score, but the time underneath. So 5%, which is this area over here, has means that are less than 27.58 minutes.